The Unit 4A study guide. Now let's look at some Concept 18 problems. We're going to convert between rational exponents and radical expressions, applying those properties of exponents, and we're going to do this without a calculator. So 14, we have 25 raised to the 3/2 power. So let's rewrite that as a root. So that's the square root of 25 raised to the 3rd power. Take the square root of 25, which is 5. Now take 5 raised to the 3rd power, which is 125. Number 15, 256 raised to the 3/4 power. So start by rewriting that as the 4th root of 256 raised to the 3rd power. Take the 4th root of 256, which is 4. Then take 4 and raise it to the 3rd power, which is 64. So see, we start with the root first and then the power. Number 16, 4 to the 3/2 power. We start by taking the square root of 4 and raising it to the 3rd power. So square root of 4 is 2. 2 to the 3rd power is 8. And finally, number 17. So start by rewriting it as the 3rd root of negative 125 raised to the 2nd power. We do the root first, which is negative 5, and then negative 5 times negative 5 gives us 125. I'm sorry, it gives us 25. Let's continue with 2 more Concept 18 problems where we are rationalizing the denominator. So when you have an expression like in number 18, what we need to do is we need to multiply by the opposite of the denominator. So the numbers are the same, but the sign is opposite. Then we multiply straight across numerators and denominators. So up top, we just get the square root of 2 plus 4. In the denominator, we're going to take both of those expressions multiplied together. So square root of 2 times itself is 2. Then we get 4 square roots of 2 minus 4 square roots of 2 minus 16. So all I did there was just distribute. Now notice the 2 middle terms will subtract out, and we'll be left with 2 minus 16 in the denominator, which is negative 14. See how we no longer have a radical expression in the denominator, which is our goal. Now, number 19, let's use that same method. So we're going to multiply by the opposite of the denominator, so 1 minus square root of 3. Up top, we will just get that, 1 minus square root of 3. In the denominator, we will distribute and get 1 minus a square root of 3 plus a square root of 3 minus 3. The middle terms will subtract out and we'll be left with our numerator over 1 minus 3, which is a negative 2. Now we're going to do quite a few problems for Concept 19, solving radical equations and checking. Make sure that you pause the video if you need to, just to catch up on the work. So we want to isolate the radical. On number 20, notice that the square root is isolated, so now we're ready to raise each power side to the power of the radical. So we're going to square each side. We'll get x plus 1 equals 4 squared, which is 16. Now we'll just get x by itself by subtracting 1. Remember, we have to check these answers, so we're going to plug in our x value into the original equation and make sure that the left side equals the right side. So we get square root of 16, and does it equal 4? It does. When we do a check step, we take the positive square root, and so that gives us positive 4 equals positive 4. Now on 21, notice we have one square root equaling another, so we are ready just to raise each of those to the 2nd power. So we'll get 5x minus 3 equals 2x plus 12. Get your x's on one side by subtracting the 2x over, and then numbers on the other by adding 3. Then just divide both sides by 3 to get a potential answer for x. Now let's check that. So we're going to plug in 5 into both places for x. So on the left side, we get square root of 25 minus 3 equals square root of 10 plus 12, which gives us the square root of 22 equals square root of 22, which is a true statement. So that solution works. Now look at number 25. Notice we have a negative 5 multiplying outside of that square root. So the first thing we want to do is divide both sides by negative 5. So we'll get x plus 4 equals negative 9. We can square both sides and simply get x plus 4 equals positive 81. Subtract your 81, and our potential answer is 77. Now let's check it back in the original. So we're plugging in for x, and on the left side, we get negative 5 times the square root of 81. Square root of 81 is positive 9, so we get negative 45 equals positive 45, which it doesn't. So that is a check step that shows you that solution does not work. Since that is our only choice, we have to say no solution. So remember on your test to check all your solutions, and if you get one solution that does not check, then you have to eliminate it and say that there is no solution for that problem. Look at number 23 with me. We are ready just to square both sides, so we'll get x squared on the left side equals 2x plus 8. We have a radical to solve, so let's move everything over to the left side. We'll subtract the 2x and the 8. Now let's factor this. So numbers that will multiply to give us negative 8 and add to give us 2, which is negative 4 and 2. So we can factor that as x minus 4 times x plus 2. Set those each equal to 0 and solve. So we get x equals 4 and x equals negative 2, possibly. So let's check 4. I'm plugging that in for x on both sides, and I get positive 4 equals the positive square root of 16, which is 4. So x equals 4, that checks. Now let's try negative 2. So plugging it into our original, we get negative 2 equals the square root of negative 4 plus 8, or the square root of 4, which is positive 2. So negative does not equal a positive, so that means that solution does not work. So I need to cross it off. Now look at 24. We need to isolate the radical. So first let's start by subtracting the 6 over. Then let's divide both sides by 2. Now we're ready to raise each side to the power of the root. So this time it's to the 5th power. So we simply get x equals 32. Let's plug 32 back into our original equation. So we get 2 times the 5th root of 32 plus 6, and we're seeing if that will equal 10. So we get 2 times 2, which is 4. 4 plus 6 equals 10. So yes, 32 does check. Now let's look at number 25. So notice that our radical is isolated, so we are ready to raise both sides to the 2nd power. We'll get negative 11x plus 92 equals x minus 6 times x minus 6. I need to distribute that out. So x times x is x squared. Then I get 2 negative 6x's, which is a negative 12x plus 36. Now I see that I'm going to have a quadratic equation to solve. So let's move everything over to the right side of the equal sign. So I'm adding my 11x and subtracting 92. 0 equals x squared minus x minus 56. I am going to try to factor that. So numbers that multiply to give me negative 56 and add to give me negative 1. So let's try negative 8 and 7. So our factors are x minus 8 times x plus 7. Let's set those each equal to 0 and get our two possible solutions. So that will be x equals positive 8 and x equals negative 7. Now let's start by checking 8. So we're going to plug it into the original equation into both places for x. So we get the square root of negative 8 plus 92 equals 8 minus 6, or the square root of 4 equaling 2. And that's true because 2 does equal 2. And now let's try negative 7. So plugging that in, we get the square root of positive 77 plus 92 equals the square root of negative 7 minus 6, which is negative 13. So then the square root of 169 is positive 13, which does not equal negative 13. So negative 7 does not work as a solution, so we need to cross it off. Now let's look at this application problem. So the speed of a vehicle just before the brakes are applied can be estimating by using the formula. So S stands for speed equals 28.75 times d, all raised to the 1/2 power. So where S is the speed in miles per hour of the vehicle and d is the length in feet of the skid mark the vehicle leaves. So we're going to be answering two questions. How long is the skid mark of a car traveling 45 miles per hour? We're going to round to the nearest hundredth. And our second question is, how fast would the car be going if the skid mark was 17 feet? So the first thing I'm going to do is just write down my formula in my space, and you do that with me. So S equals 28.75 D raised to the 1/2 power. Now in green, I'm going to answer the first question, how long is the skid mark? So I'm going to be solving for D, and I'm going to plug in 45 for S. So do that with me. So we'll get 45 equals 28.75 times D raised to the 1/2 power. The first thing we need to do is we need to get rid of that power. So we're going to raise it to the reciprocal power, which is 2 over 1, or just the second power. So we'll do that for both sides. 45 raised to the second power is 2025, and that will equal 28.75 times D. Now we can get D by itself by dividing, and then rounding to the second decimal place, we'll get a skid mark of length 70.43 feet. Now let's answer the second question. I'll do that in purple. How fast would the car be going if the skid mark was 17 feet? So now we're going to be solving for S and plugging in 17 for D. So S equals 28.75 times 17 raised to the 1/2 power. Simply do that on your calculator, and let's round to the second decimal place. So approximately 22.11 miles per hour. These last three problems will review concept 20, where you are graphing square and cube root equations, then stating the domain and range. So when you look at each of these, just make sure that you notice whether it's a square root or a cube root, and then recall back from the notes in your practice what the parent graph looks like. So let's look at 27. F of x equals 2 times the square root of x. So let's talk about the transformation first. That 2 out front is going to give us a stretch by 2. So that graph is going to jump up a little further than normal. Now I'm going to make an XY table. So I know that I can't have any negatives for a square root, so I'm going to start by plugging in 0 for x, and then numbers that are perfect squares. So I'm going to plug in 0, 1, and 4. Notice I've done the math. So square root of 0 is 0, times 2 is 0. So that's my y value. Square root of 1 is 1, times 2 is 2. So that's my y value. Square root of 4 is 2, times 2 is 4. Now I'm going to plot these points. And then remembering that this graph has a starting point, and then we'll go off infinitely into the opposite direction to the right. Now I'm going to come back and do the domain and range in a moment, but let's look at number 28. Notice 28 is a cube root function, so I get in my mind that this is a different shaped graph. It's what I call a propeller shaped graph. Let's look at our transformation. So that graph is going to be shifted to the left 1 because of that 1. Let's do an XY table. Now I know because of the shape of the graph, I'm going to have numbers in the negative, the 0, and the positive. So I'm going to start by just giving my middle point, which has been shifted left 1. So I'm going to plug in negative 1 for x, do the math, and get 0. Then I'm going to plug in numbers around that. That will work well. So I plugged in negative 2 and negative 9, which when I do the math gives me negative 2 and negative 1. And then I'm going to plug in 0 and 7. I'm plotting those points and then remembering what the shape of the graph looks like, which is, again, what I call like a propeller shape. And it will continue in either direction, so I put my arrowheads. Now, because that graph stretches all across the x and y axis, I don't have a limit on my domain and range. So it is all real numbers. However, let's jump over and look at the square root graph. This is limited. So I look at my x-axis, notice that my x values start at 0, so my range is all the x's that are greater than or equal to 0. I look at my y-axis and notice that the graph starts also at 0, so my y's are all those that are greater than or equal to 0. Now let's go back to 28, our cube root graph. So again, that doesn't have any limitations. It spreads out over the x and y axis. So the domain and range are both all real numbers, and that's always the case in a cube root function. Now, 29, back to a square root function. So we notice it's going to shift left 4. So in my table, I'm going to start there, and I'm going to plug in numbers that are easy to take the square root of. So negative 4 is my starting point, and then I'm going to plug in negative 3 and 0. Plot those points and know that that graph starts at negative 4, 0 and goes off to the right infinitely. So my domain is going to be all the x's that are greater than or equal to negative 4. But my range will still be all the y's that are greater than or equal to 0. All right, that concludes our study guide problems for this unit.